Hello, so today we are going to be talking about rules 4, 5, and 6 for exponents. So we've already talked about rules 1, 2, and 3. There's one video called adding exponents and the other called multiplying exponents. Please make sure you watch those before you watch this one if you've not done so already. Those will explain some of the rules that we're going to be doing today and some of the things we're applying. So it says rule number 4, dividing exponents. Well, my question is, what do I do if I have a fraction with exponents? So sometimes we'll see the fraction like we have over here, 4 to the 7th divided by 4 to the 3rd. You may also see this just with variables as x to the 7th over x to the 3rd. So the best way to explain this is to think about it in factored form. If I factor it out and have factored form right here, 4 to the 7th means I have 7 4s being multiplied by each other. 4 to the 3rd means that I have 3 4s being multiplied by each other. Well, when I multiply and I have the same thing on top and bottom, those just divide out to 1, aka cancel out, we say. So if I cross off a 4 on top and a 4 on bottom, another 4 on top, another 4 on bottom, another 4 on top, and another 4 on the bottom. Well, I've reduced everything that I can for my denominator. There's nothing else in the bottom that I can cross off, but I'm left with these 4 4s in my numerator, leaving me with 4 times 4 times 4 times 4, or we can say that that is 4 to the 4th. When I multiply that out, it becomes 256. So if I think about a rule, because I can't solve this one out to be one number if I only have variables, the rule that I'm using is called quotient of powers property, or if I divide numbers with the same base, both of these bases are 4s, both of these bases are x's, I'm going to subtract the exponents, top minus the bottom. This is key, that's why there's a big star there. Whenever I do my subtraction, it's always top minus the bottom, even if that means a bigger number on the bottom, yielding a negative exponent for my answer. So if I have x to the 7th over x to the 3rd, that becomes x to the 7 minus 3, or x to the 4th, which is really the same thing I got whenever I did the whole factorization out. So the key here, subtract top exponent minus the bottom exponent. Here's some examples. We'll start off with this top one. I have x to the 12th divided by x to the 3rd. Well, this becomes x to the 12 minus 3. Well, 12 minus 3 gives me x to the 9th. Not that bad. Y to the 7th over y to the 3rd. Well, I do my top exponent minus my bottom exponent. So y to the 7 minus 3, or y to the 4th. Ooh, so this one down here has a big star by it, number 3. It says 15x to the 8th divided by 5x to the 3rd. Whenever I have problems like these, your numbers are separate from your letters. Those are two separate problems connected by multiplication. Just because you have numbers attached to your letters, and when I talk about numbers, I mean these coefficients, that does not mean those coefficients have those exponents. So if I look at what I have in green, it's 15 divided by 5. Well, 15 divided by 5 gives me 3 on top and 1 on the bottom when I reduce it. Well, then for my x's, or my variable, I have x to the 8th over x to the 3rd. Well, 8 minus 3 gives me x to the 5th on top. So what I'm left with is 3x to the 5th over 1. Since anything over 1 is just itself, my final answer is 3x to the 5th. Be really careful with these problems. That's where there's this big star. Be really careful that you don't put those exponents with those numbers. Those exponents are only with your variable since there's no parentheses. Well, we have another example over here. It says x to the 11th over x to the 7th. X to the 11th times y to the 2nd over x to the 7th. Well, same idea here. I have two different variables. I'm going to look at just my x's. My x's say x to the 11th over x to the 7th. Well, that gives me x to the 11 minus 7. Well, whenever I do that subtraction, I get x to the 4th. Well, then I have y squared. Is there anything I can reduce that y squared with? Are there any y's on the bottom? No. So it just becomes y squared brought down. So you have x to the 4th times y squared. I can't reduce that with anything. So that's my final answer. So we have a special case, or not really a super special case, but just something that we'll see. If you have anything raised to the 0 power, it equals 1. So what do I do if the exponent is 0? That piece equals 1. So if we think about this conceptually, x to the 0 equals 1. Think about if I had x to the 3rd over x to the 3rd. Well, that would be x to the 3 minus 3, or x to the 0. But anything divided by itself, we know equals 1. So this would automatically equal 1 from the start, meaning that x to the 0 equals 1. So in this example, number 5, I have x to the 0 times y to the 4th. Well, just that x to the 0 piece becomes 1, and I bring down my y to the 4th. Well, 1 times y to the 4th just equals y to the 4th, and that's my final answer. Over here, my numbers and my coefficients are separate than my variables. 15 divided by 5 gives me 3. X to the 3rd divided by x to the 3rd gives me x to the 0. But we said anything raised to the 0 equals 1. So I have 3 times 1. Well, 3 times 1 is just 3. And that's my final answer. Be really careful on those, not to cross everything off and make it a 0, or make it a 1. Okay, then I have x squared y to the 0 divided by x to the 7th. When I just look at my x's, I have x to the 2 minus 7 times y to the 0. Well, we said that y to the 0 becomes 1. Well, x to the 2 minus 7, that becomes x to the negative 5. Well, then I get x to the negative 5 times 1, which gives me x to the negative 5. Well, what do we do when we have an exponent that's negative? What do I do in this case? We have one last rule. This is rule number 6, and this rule deals with negative exponents. So rule number 6, negative exponents. So if you have a negative exponent, that means it's the reciprocal of that number raised to the positive power. So if we think symbolically, because sometimes that helps me more to see things visually, a to the negative n is just 1 over a to the n. So in my last example, I had x to the minus 5. That would become 1 over x to the positive 5. When the exponent goes to the bottom, if it starts off negative, it becomes positive on the bottom. But the like is true if you have 1 over a negative exponent. When you bring that to the top, it becomes positive. So if it's negative on top, bring it to the bottom so it can become positive. If it's negative on the bottom, bring it to the top so it can become positive on top. Oh, so this first one we just did, x to the minus 5, would be 1 over x to the positive 5. If it's negative on top, bring it to the bottom, and it becomes positive. Number 8, I have x to the minus 4 times y to the third. Well, only this piece goes to the bottom. If I think about this being a fraction, only the variable with the negative exponent goes to the bottom. That y to the third is positive. The exponent's positive, so it stays on top. But my x with the negative exponent of a 4 goes to the bottom to give me y to the third over x to the fourth. Both of those exponents are now positive. If it's positive on top, it stays on top. If it's negative on top, it goes to the bottom. Okay, this one right here, I have y to the 12th over y to the negative 8. Since this y piece is negative on the bottom, I'm going to bring it to the top. Well, on top I already have y to the 12th. Now I'm just going to bring that y to the 8th on top of my fraction 2. Well, y to the 12th times y to the 8th, when I multiply like bases, I add my exponents, so I get y to the 20th over 1. You can also think about this as using your property of subtracting top minus the bottom. My top exponent was 12, and I subtracted a negative 8, making that positive, so that would give me y to the 20. Whichever way you think about it, you'll get the same answer, but that's another way of looking at it. Number 10, the last one, this piece down here, y to the negative 8th, the exponent's negative, so I bring it to the top, and I get x to the 10th, y to the 4th, times y to the 8th, all over 1. Multiply like bases, you add these exponents, and you get x to the 10th, y to the 12th. And that's your final answer. So these are rules 4, 5, and 6. For exponents, take some time and try the back page by yourself.